So this is the triple chemistry paper for 2003. First question, kind of nice and easy. Different colours of a pH universal indicator scale. And then different substances. Name one substance that would be an alkali. I've gone with hand wash, but you could have gone with drain cleaner. State which substance is the strongest acid. So that's going to be battery fluid, because we know that red is a higher pH than the orange. Give the correct formula of sodium hydroxide. So it's Na plus OH minus. And if we were to do top, swap, drop, because they're exactly the same charge, it doesn't matter, you would have added NaOH. The student carried out some reactions using hydrochloric acid. She recorded the following observations. Reaction A produces a gas. Give the letter of the other reaction that produced a gas, the observation that shows a gas was produced. C, because there was fizzing, that would be the gas being given off. One of the gases produced is hydrogen. Describe how you test for hydrogen. The test is lid splitting, and the observation would be a squeaky pop. Give the letter of the reaction, which is the least exothermic. So least exothermic is going to be the lowest temperature increase. So that's going to be C again, because it's got the lowest temperature change. Lovely labelling of the fire triangle there. Complete the section of the fire triangle. So we've got oxygen, fuel, and then heat. Complete the following sentence. Explain how a fire is extinguished by the following methods. A fire blanket removes the oxygen from the fire triangle. Cutting down trees in a forest removes the fuel from the fire triangle. And then you had a series of numbers and you had to fill in the blanks. As you can see, there are 8 hydrogens on this side, so we need to make sure that there's also 8 hydrogens on this side. So this is the setup of combusting alcohol. You've got your alcohol there, and then you've got the water and this kind of setup there. So the starting temperature of each water is 18 degrees. Calculate the final temperature. So you're going to add the final temperature of ethanol, which will be 19. So add them together and you should have got 37. Tick the question the class was trying to answer. Which alcohol gives out the most heat energy? The other ones kind of don't make sense. MR, that would have been lovely. So you've got 1 carbon, 12 times 1. You've got 4 hydrogens, 1 times 4, and then you've got 1 oxygen, and the answer would have been 32. Circle the apparatus labelled X. That is a conical flask, because it's got that kind of triangle shape, whereas a beaker would be like that, straight. Give the name of Y and state what was to be seen when carbon dioxide is bubbled through it. That's lime water, and it should turn cloudy. The chosen temperature for this reaction is 35. Tick the correct box and state why it would not produce at 90 degrees. It's because the enzymes in the yeast would have denatured. Lovely then kind of values to plot a graph. Now you can see on mine that I don't think my ruler was completely straight, so be really careful of that, but it is a straight line through, and you can see that I've done some extrapolation, which will be on the next page. So use the graph to find the volume of carbon dioxide produced after 20 minutes. So find 20 minutes like you can see on the graph, and then go across and down. Use the data to estimate how long it would take to produce 100 centimetres cubed of carbon dioxide gas, assuming that the rate does not change. Assuming that is a straight line, so it should be a steady rate the whole way through. Okay, so every 25 minutes. So this is kind of data from the graph. Yours might be slightly different. I'm taking it to be that it's 25 minutes equals 40 centimetre. Sorry, the other way around. That every 40 minutes, 25 centimetres cubed is produced. So you want to get 100, so you times that by 4. So then you times that by 4 to work out the answer, and you would have got 160 minutes. Blank page. Then we're looking at electrolysis. Remember, straight away you should be writing panic and oil rig, just so you've got them to help you complete electrolysis. Aluminium oxide is a compound of aluminium and oxygen. Cryolite is used to lower the temperature, so less CO2 is used, less electricity is used. Okay, electrolysis uses a lot of electricity energy. Aluminium is produced as a liquid. Okay, molten means it is melted, so that means it is turned from a solid to a liquid. So they've given you the ions, you don't even need to find them. Remember, it is on that table at the back though. And give the formula. So you wanted to do top, swap, drop. So Al3O2, put them at the top, Al3O, swap them Al2O3, and then drop them Al2O3. Tick the box that explains why iron is reduced by heating with carbon in the blast furnace. State why aluminium oxide cannot be reduced this way. Aluminium is more reactive than carbon. Then there was a lovely 6 marker. Describe how the properties of copper make it suitable for each of these uses. So that's wires, that's obviously pipes, and then that's pans. And you can see here the first one, electrical wires, is ductile, can be drawn into wires, and it's also a good electrical conductor. You didn't get the mark unless you did the 2 things. So you had to say ductile, the uses, it can be drawn into wires. Saucepans, there were loads, malleable, good thermal conductor. And then water pipes, again, corrosive resistive, non-toxic, safe for drinking water. Okay, that was a really nice 6 marker. Another blank page. Then a lot of information to read about fertilisers containing nitrogen and kind of graphs. And then there were some questions to answer. Tick 3 boxes that state the effective fertiliser use, which can contribute to the death of aquatic animals. This is a lot of year 10 information from biology. Okay, so fertilisers run into the waterways, plant growth in the river and lakes increases, aquatic animals do not have enough oxygen. Remember, because the sunlight, there's all that algae on the top and the sunlight can't get in. State whether the information in figure 1 and 2 shows a link between the number of people living on each continent and the amount of ammonia used. Give reasons for your answer. Larger the population, the more ammonia used. Africa is an exception, the second largest population, but the 4th largest ammonia growth. Give the name of this compound. It's ammonia sulfite. Again, you could have got that from the table of ions. They would have come up on the table of ions. You could have formed the compound or the name of the compound. Tick the box that gives the correct reason why plants need nitrogen. They use it to make protein. 1.5 grams of fertiliser treats an area of 75 metres squared. Calculate the mass needed to treat an area of 15 metres squared. So I worked out how many times 15 goes to 75, and that was 5. And then I divided the 1.5 kilogram bag by 5, and that gave me 0.3 kilograms. Okay, and I had to convert it then, so times it by 1,000 to get to grams. Balance the equation. Look at what you've got on your reactants and your products. You've got 2 nitrogens, so that means you need 2 nitrogens. You've got 3 hydrogens, well 6 then when you do it, so you need 6 hydrogens on each side. What does that symbol mean? Reversible reaction. Name the catalyst used. So this was a little bit of core knowledge that we had to learn in the Haber process. State where a catalyst is used increases the rate of reaction. Right, so tables A to E, so different substances. Give 2 letters of substances which are metals, D and E. The reason for that is because they can conduct electricity, and they've also got really high melting and boiling points, and they are malleable, all key properties of metals. Give the letter of substance which could be carbon dioxide. I've gone with B, can't conduct electricity, low boiling point, not malleable, but is soluble in water. And then give the letter of substance which is a giant ionic structure. The reason is carbon dioxide, sorry, just go back to that one if you're thinking, oh, is it soluble in water? It is, but carbon dioxide isn't going to have that type of boiling point. Okay, because it naturally exists as a gas. So that would be extreme temperatures for it to turn into a gas. Give the letter of substance which is a giant ionic structure. This one straight away, because that's a property of ionic compounds. Complete the dots and cross diagram to show the outer electrons of chlorine. So they have 7. Again, a really nice question. They've given you quite a lot of information there. Remember, you've got your share zone with them 2 electrons. Again, a little bit of an ionic bond. The diagram shows the electron structure that occurs when V and Y form ionic compounds. The dot and crosses show the outer electrons. Give the charge of each one. So V has lost 2 electrons, so it's +2 each. Y has gained 1 electron, so it's minus or -1. Ionic formula, you're going to have 1 V, 2 Y, so it would be Vy2. Potassium oxide is another ionic compound with a relative formula mass of 92. That's the MR. Calculate percentage of potassium oxide in K2O. So this is again from last year. Potassium is 39. There are 2 potassiums. 39 times by 2 divided by 94 will give you 83%. A student made copper sulfate crystals by reacting copper carbonate powder with sulfuric acid using the following method. State how you would carry out stage 4 to get the largest crystals possible. Leave to dry for a few days on a windowsill. Crystals of copper sulfate could also be made using copper oxide instead of copper carbonate. State the observations. There would be no fizzing or bubbling because no CO2 would be produced, because there shouldn't be a gas being produced if you're using oxide. And then complete the symbol equation. It says here copper sulfate is one of the products, so again you would just do top, swap, drop. They are both 2 charges, and then remember that's an alkali, that's an acid, so you should make H2O. Lovely energy profile, and it's got to label it. Energy change reaction is C, is always the difference between the reactants and the products. Calculate the energy of the reactants, that's A, and the activation energy is always between the reactants and the hump. Okay, reactants and the hump. Give the meaning of activation energy, minimum amount of energy required for the reaction to take place. State how the energy profile shows that this is an exothermic reaction. Reactants are higher than products. Lovely blast furnace here. State the changes, so the changes of state. So that means are you moving from a solid, a liquid or a gas, happening at X and Y. X, you're going to evaporate, you're going to turn from a liquid into a gas, and then they condense when they reach their boiling points. Explain why each fracture is formed at different levels, different hydrocarbon lengths. Longer the chain, the higher the boiling point. Then it's given you that equation, mass times 4.2 times temperature rise. They've told you the difference in temperature, so the first thing you have to do is work out the temperature rise, which would be 19.7. You've obviously already got that number, and then the mass of water they told you was 100 grams. Times it all together, and I've done that, got that number, and then it's going to give you an answer in 2 significant figures. That's why I've rounded it. Cracking then, you start with 16 and 34. You need to make sure on this side your numbers add up to 16 and 34. Okay, so that's why I've done C6H12. 2 conditions needed for cracking: heat and pressure. What is meant by the term unsaturated? Has a double bond. And then state where there's high demand for the following products. Octane is used to make petrols and ethene is used to make plastics. End of paper. Lovely extra bit. Remember, you've always got your table of ions and your periodic table.